Hey, you like my beard today? I thought I looked it like Santa. All right. Let's identify proportional relationships in a graph. So before we identify proportional relationships in a table, now we're looking in graphs. So any proportional relationship can be graphed, like two cars in the following interactive. As you may notice, point values of the cars are also proportional, like values in a table. This makes sense because the table values are just the x and y values on the graph, right? So in 6 hours, a blue car drives 240 miles and the green car drives 300 miles. Can you figure out which one's faster? Okay, so if in 6 hours this one goes only 240 miles and this one goes 300 miles, obviously the green one's going faster. It doesn't let me go to 240, but if I go here, you can see the blue car is slower than the green car. Okay. So you both want to leave at 10 a.m. You get there, you drive 240 miles. Your friend drives 300 miles. So who's faster, you or your friend? Your friend. So it's either going to be 30 and 50 or 40 and 50. They're not the same, and you're not going faster. I'm going to go with this one. Can you guess why? All right. Finding unit rates. Think of it that way. Any proportional relationship can be graphed like the two cars. You notice that point values of the cars are proportional, like the values in a table. Okay. Let's try a turkey. So this table shows cook times for a turkey at 325 degrees Fahrenheit. Drag the turkey to the graph so that it lines up in the values in the table. So if I line it up exactly, undercooked, perfect. So 12-pound turkey, about 180 minutes. It doesn't seem to be the same here. I don't know why. It will take a 270 minutes to perfectly cook an 18-pound turkey. What do you think? Here's 18, 260, 280. So I'm going to go with 270. True. Yes. So the proportional relationship on a graph looks like this. All right, it is important to note all proportional relationships pass through the origin when graphed. The origin is the point 0, 0 on the graph. It is also the point where x and y axes intersect. You can conclude that the point 1r represents the unit rate, right? Everything starts here at 0, 0. If I do 1 unit, if I go to one spot, 1-pound turkey, and that would tell me exactly where this is. It works on all of them. So let's take a look at this one down here. All right. So here's Abby. She's running for a half marathon. In 17 minutes, she runs 2 miles. So that's this one right here, this green one. 42.5 minutes to run 5 miles. That's this blue one. And then 93 minutes to run 11 miles. That's this red one. Notice when the line is black. If I pull one of these off, you've got 3 different colors. If I put it exactly on, the line goes black. Okay. What if I wanted to figure out 1? So if I do 1 minute, right there, 1 minute on the line, it should be, oh gosh, I can't even get it. 8.5. So use the interactive to figure out. So the relationship does not appear to be proportional. Well, it's a straight line going through the origin, so it must be proportional. So that's this one. Here, right here, if she runs for 1 minute, or if she goes 8.5 miles, 8.5 minutes, she goes 1 mile. So 8.5 minutes to run 1 mile. That makes sense because 8.5 miles in 1 minute. It's a long way. Yay. So you try the next one. So a graph and a table both represent proportional relationships. The graph of a proportional relationship is the line that goes through the constant rate and goes through the origin. The point 1r represents the unit rate.